Interference fringes or the interference pattern is the topic that we are going to see today. So in the last class we have seen what is the difference between constructive and destructive interference. For constructive interference, crest of one wave meet with the crest of the other wave, or the trough of one wave meet with the trough of other wave. During destructive interference, crest of one wave meet with the trough of the other wave. So the net displacement will be 0. During constructive interference, net displacement will be either A plus A, 2A, or minus A, minus A, minus 2A. So during constructive interference, the intensity will be maximum, and during destructive interference, intensity will be, resultant intensity will be minimum. So here we can see two sources. We have a cardboard here. I have placed a cardboard. This is a cardboard. The cardboard is having two holes, S1 and S2. And I have placed a source of light S here. This is a source of light. This source of light will produce spherical wavefronts like this. These are the spherical wavefronts. The bold lines of the spherical wavefront indicate the crest of the wave. So the bold lines indicate crest and dotted lines indicate trough. So these are the spherical wavefronts from the source of light. These wavefronts will pass through these two slits S1 and S2. Here S1 and S2 act as two coherent sources. From S1, these are the wavefronts. First wavefront means this corresponds to crest, dot line corresponding to trough. Second crest, then second trough, like that. So black color I have used for the wavefronts from source S1. Similarly from S2, these are the wavefronts. First crest, then trough, again crest, again trough, and so on. So the wavefronts will propagate forward and it will fall on the screen. This is a screen. Now here you can see that exactly along the center, you can see that the troughs are meeting here. The troughs corresponding to both sources are meeting here. Here troughs are meeting, here crests are meeting. Again here troughs are meeting. So here troughs or crests are meeting. So in the first point you can see the blue dotted line meet with the black dotted line. Here you can see blue bold line meet with the black bold line. Again the dotted lines meet here. So this corresponds to constructive interference. So at this point on the screen we have a bright spot. A bright patch of light or a bright spot will be visible on the screen. So the waveform we can represent here. This point corresponds to constructive interference, and here we will have a bright region. For the bright region, what will be the amplitude? It will be crest having an amplitude plus 2A and trough having an amplitude minus 2. If the waveform for the interfering from S1 and S2, we can write, if it is S1 and S2, I consider two sources of light, two slits. From S1 we have light having amplitude A. From S2 also we have a light having amplitude, same amplitude, plus A corresponding to crest and minus A corresponding to trough. Then the resultant amplitude during constructive interference will be A plus A 2A, here minus A minus A minus 2A. So at the center we will get a bright portion. So this is called a bright band. Now we can see these points where crest of one wave meet with the trough of the other wave. So here you can see crest means a black bold line meet with a blue dotted line. Again crest meet with the trough. Here also crest meet with the trough. So these points corresponds to what? Dark. Means there is no intensity at all. It will be cancelled. Plus A cancelled with the minus A. So this corresponds to destructive interference. Similarly here also we can see destructive interference. So here crest meet with the trough. Again crest meet with the trough. Crest meet with the trough. So these points, when you draw the remaining wavefronts, you can see that up to this point the crest is meeting with the trough. So the resultant amplitude will be 0, resultant displacement will be 0, and this corresponds to dark band. So at the center we have got a bright band, on either side we have got a dark bands. So we will get alternate dark and bright pattern on the screen. This is called a fringe. So on the screen we can see alternate dark and bright bands. This is called interference pattern or interference fringes. Okay, so if you have a screen like this, if you are seeing the screen, this is a screen surface, the side view, the front view of the screen, we can say the center there will be a bright band. This we can consider as a bright band. Then on either side we'll have dark, but this will be one dark band and this also will be another dark band. I just shade the dark bands. This will be a dark band, this also will be another dark band. At the center we'll have a bright band. So a similar pattern will be visible on the screen. Such a pattern is called interference pattern, or we can say interference fringes. This pattern is known as fringes. So at the center we have a maximum intensity, resultant displacement will be maximum. So amplitude will be A plus A 2A, here minus A minus A 2A. At these points we know that here crust is meeting with the trough. Crust is superimposing on trough. Here crust is superimposing on crust, trough is superimposing on trough. What happens? We have here a constructive interference. And these 2 points corresponding to points where destructively the crust is meeting with the trough. So what happens? Interference will be destructive and net displacement will be cancelled. So net resultant displacement is 0. We don't have a wave at all. So only we get a horizontal line like this. Here we have variation oscillations. Here we don't have any variation, means net intensity will be 0 at these points. So these points corresponds to dark bands. The center corresponds to bright band. So that's about interference fringes. Okay, thank you.